Hi students, welcome back to my YouTube channel SADHIK Physics. So today we are going to discuss wave optics. No, I know most of the students know they feel difficulty in understanding the wave optics. No, and so they face lot of difficulty in the problems, all this one. No, so but if you really observe this video or if you see this video, no, so definitely you will come to know that this wave optics is the one of the easiest chapter and very large every time. No, in any competitive examination, no, definitely you can expect the questions from this. Okay, so we will learn step by step. No, so in this video we will just concentrate on the introduction to the Huygens wave theory and interference only. So then next we'll go for Young's double slit experiment. No, then after diffraction, then after polarization. No, so we will discuss detailedly one by one now. Clear? So if you see my videos, no, you will understand that how much easily you are learning the physics. No, so you can learn physics very easily. Please, if you do not subscribe, no, subscribe to my channel. So and share this video so to those who want to learn the physics. Clear? So now first let us go for discussion about this wave optics. Okay, in the name itself is there, wave optics. Optics means what? Light. So therefore here optics is light now. So therefore light is considered to be like a wave, and it is also considered to be like a particle. How that wave, how that light is moving, therefore if you switch on that, automatically from the source on, therefore it will travel some distance now. How that light is propagating, how that light is moving, how that much fast it is moving. No, therefore to explain how this light is propagating from one place to another place. So therefore there are so many scientists, no, explain different ways. No, so one scientist like a Newton. So Newton, what he said now? Newton, what he said now? Light is having some particle nature. It is particle. That means light. If a source of light is there, no, like a bulb is there, a candle is there, no, therefore it is going to emit some particles. That particles he named it as like a corpuscles, no, right? So therefore every luminous body, they are going to emit the corpuscles in all the directions, no, clear? So therefore, and Newton suggested that light is in the form of like a particle nature, therefore corpuscular theory, and he explained something, no, right? So therefore he explained like a reflection, refraction also he explained slightly. So he couldn't explain therefore interference and diffraction and polarization. No, he was not able to explain these concepts now, right? So that means therefore here Newton only assumed that it is in the form of like a particle nature. So therefore Huygens, so therefore he assumed that light will travel in the form of like a wave, right? So particle means what? A particle means it is having mass, so velocity, momentum, therefore mv, and kinetic energy half mv square, like that. No, this particle nature. No, wave nature means what? It should have wavelength, frequency, velocity of the wave, wavelength into frequency, phase difference, path difference, no, right? Like this, these concepts, no, which are involved in the waves. No, Huygens assumed that light will travel in the form of like a wave, so therefore it will propagate in the form of like a wave in all the directions. No, so therefore Huygens explained reflection, refraction, interference, diffraction. Therefore these are the four things. No, he explained. No, therefore he could explain with the help of wave nature. No, therefore most of the properties. No, but photoelectric effect is there. No, with the wave nature it would have not able to explain. Therefore light is showing all these properties. What are the properties? No, it will shows reflection, refraction, interference, diffraction, polarization, photoelectric effect, Compton effect. So these all the properties, no, it will shows. But here reflection, refraction, interference, diffraction, this was explained by the Huygens. No, but photoelectric effect so was explained by this like a particle nature, not Newton's corpuscular theory. So therefore photoelectric effect will be assumed like a, so it can be explained in the form of like a particle nature. Assume that particle, name it as like a photon. right? That means, so we know that light can be explained in both the situations, like some phenomena can be explained in the particle nature, some phenomena can be explained in the form of like a wave nature. That's why light has a dual nature. So dual nature means it is having wave nature and it is having particle nature. Sir, when we have to use that particle nature, when we have to use wave nature, no? Therefore, when light is interacting with a matter, suppose if any time light is interacting with a matter, that means light is falling on a photosensitive film, it is emitting the electron. That means light is interacting with a matter, at that time you have to assume particle nature. When light is interacting with the light only, so therefore at that time you have to go for wave nature. In this way you can take it as light as having the dual nature, that is particle nature and wave nature. Therefore, the interlink between this wave nature and particle nature was explained by our de Broglie's hypothesis, de Broglie's matter waves, wavelength is equals to h by p. Already I did the video dual nature of the light, so detailedly I explained everything. So in that video, just go through it, that concept, matter waves, clear? So what this corpuscular theory did, how this Huygens explained, so in this chapter we are going to fully concentrate on this Huygens wave theory only, right? So this Huygens wave theory we will discuss detailedly. We will discuss what is Newton corpuscular theory also. Let us see here, right? I think if you are able to see it, it's fine. If you are not able to see, therefore I will explain. So just we'll go for like look at ever quickly. So Newton corpuscular theory, what did he say? Light emits like a little invisible particle known as corpuscles. So light is therefore any source of the light, they are going to emit the corpuscles. That corpuscles we are not able to see it. It is invisible, right? So they are constantly emitted by all the luminous sources in all the directions. That means it is going to emit in all the directions. Light will travel in all the directions, like that. When corpuscles strike the retina of our eyes, they produce a sensation of the vision. How we are able to see this one? That means corpuscles are coming and falling on our eyes, so therefore we are able to create a sensation of vision, like that. So these corpuscles travels with the speed of the light, speed of the light in the straight line. So 3 into 10 to the power of 8 meters per second. And straight line, that means it explained that light will travel in a straight line, like linear propagation. The velocity changes when there is a change in the medium. That means when it is going from one medium to another medium, therefore the speed of the light is going to change. So that means he also says that the corpuscle speeds also will be changes when it is going from one medium to another medium. Different color of light is due to the different size of the corpuscles. Therefore he explained the colors. So we are able to see the green color like that, Therefore he says that corpuscles are having the different sizes, So the different sizes will give us like a different colors. And rest mass, that means particle will be, so rest mass is 0, that means photon cannot be at rest, if it is at rest, therefore it does not have any mass. Indirectly he explained like a photon, but really, so, and also he wrongly explained one thing, therefore speed of the light in the denser medium, he said that speed of the light in denser medium is greater than speed of the light in rarer medium. So rarer medium. Therefore this was a wrongly which was explained by our Newton corpuscular theory, and he could not able to explain no interference, no nothing, and reflection also can be explained by corpuscular theory. How the reflection is explained, he said that these corpuscles will come and fall onto this one, every substance will repel the these corpuscles, due to that repulsion, therefore it is going to rebound back from this one, with a angle of incidence and angle of reflection, both are same. How these corpuscles are reflecting means every surface, so it will repel the corpuscles, Therefore in that way he explained the reflection of the light, and he explained so refraction of the light, So how we explain now? So let us see, right. Newton corpuscular theory also explains about the refraction, right? How he explained the refraction now? He said that, so every denser medium, any one denser medium is there, So if a corpuscle comes and falls onto this one now, he says that this denser medium, so denser medium no, will attract no. He said that it will attract these corpuscles no. Therefore, when it is attracted no, therefore in this rarer medium it is traveling no, but when it goes to the denser medium due to attraction, the corpuscle speed no, it is going to increase. The speed of this corpuscles no goes on increases. Due to that reason no, he said that in the denser medium no, the speed of the light is larger than the speed of the light in the rarer medium no, right? But this was a wrong statement no, which was later on proved it. So therefore, he could not able to explain any interference, diffraction, polarization no, could not be able to explain by this corpuscular theory, right? So therefore, you can remember this. So then we'll go for Huygens wave theory, right? So Huygens, so what he has assumed now, first of all, what Huygens wave theory, very important no, Huygens wave theory, what he said no, therefore at that time they know only about like a mechanical waves only they know it now, right? That means for mechanical waves compulsory the medium is required, right? So therefore the medium, right? So but light will travel in the vacuum also where there is no medium is required now. But he said that to overcome that one no, he said that total universe is filled with one medium called ether medium. Ether medium no. Therefore, so like if any luminous body is there no, therefore if it is glown, like a bulb is glown or one candle is glown, therefore what will happen now, it will create a disturbance in the ether medium, like suppose there is a water is there no, suppose there is a water will be there no, in this water, therefore if you drop one stone here, if you drop one stone, so therefore what will happen now, this stone it will create like one waves no, therefore how the waves it will be created no, the waves it will be created and it will travel in all the directions. How? So like a concentric this one no, like these waves, you might have see these ripples no, like this, you understand no? So like that it is creates a disturbance in this ether medium no, so therefore that that disturbance no is carried out of the ether medium and it will travel in all the directions no. So this is considered to be like that is wavefront. So in this water there is a wavefront is there no, therefore crust and like this no, but in that ether medium how that wavefront is created no, he said that, he explained that therefore here suppose there is a one source is there, this is one point source, this is one wavefront is there, and next wavefront how it is created no, he said that so on the wavefront no, on this wavefront no, so each and every particle, at every particle no, there will be, so each and every particle will act like a secondary source. Very important this concept no, he explained. With this concept only you could have able to explain the interference and diffraction no. Every point on this wavefront no will act like a secondary source, and this secondary source will give us like a one more wavelets no, therefore like this, right? So therefore it will create like a one wavelets now, these all are, right? So these all are called wavelets. And if you draw a common tangent on all these no, therefore if you draw a tangent, a common tangent on these wavelets no, will create like a one more wavefront. In this way therefore light will be propagated in all the directions no. And so therefore one scientist asked no, therefore okay you are taking forward wavelet no, therefore why this back wavelets no, back wavelets, so therefore it will show the impact on the incoming the wavelets no, therefore he said that only in the forward motion the wavelets only it will be the more intense no, therefore back wavelets no will be having least intense no, so that it will not show any effect on the propagation no. So therefore, so the wrong thing what he said no, therefore there is no medium is required for the propagation of the light no, and this back wavelets also he could have not able to explain no, right? So this concept right was given by explained by this Huygens, and Huygens also mostly it is this theory is based on the geometrical constructions no. So geometrical constructions, therefore in mathematics no, you might have did like constructions no, constructing the triangle, constructing the circle like that no, so mostly it is involved with the geometrical constructions no, right? So let us some more details now, we will go for this Huygens wave theory. So therefore this Huygens wave theory, so what he said, no, what is a wavefront? No, the locus of all the particles vibrating in the same phase is known as wavefront. So therefore the locus of all these points, no, so what are this one? No, this one, no, therefore this all the locus of all these points, no, clear, is a wavefront. No. Light travels in a medium in the form of wavefronts, no, right. So when light travels in a medium, the particles of the medium start vibrating and consequently the disturbance is created in the medium. Therefore that is at that time they know only the mechanical waves, no. So compulsory the mechanical wave concept only he utilized to explain the propagation of the light. Every point in the wavefront, no, becomes as a source of the secondary wavelet. This is your secondary wavelet, no. It emits secondary wavelets in all the directions, no, which will travel with the speed of the light. Therefore this is all are traveling with the speed of the light, no. The tangents on the plane of the secondary wavelets, no, represent the new position of our wavefront. That is what the tangents we need to draw it, no. Therefore that is create like a one more new wavefront, no. And this Huygens wave theory did not explain one concept, no. Therefore first wavefront how it is created. Therefore origin therefore origin of spectra. So spectral lines he did not able to explain, no. Therefore and the first wavefront, no, how it is there, no, that also we did not able to explain this one, no. Clear, right. So these are the right wavefronts, no. Suppose here we can draw some more wavefronts, no. Suppose one point source is there, this is one point source is there, point source, what it will do, no, it will emit the light in all the directions, no. It is going to emit the light in all the directions, no. So therefore it is going to create like a spherical wavefronts, no. Spherical wavefronts. Now you see, if it is very near to the source, no, therefore this curvature is more, but as you are going far away, the curvature of this one is getting reduced. So therefore if you goes far away and far away, the curvature will get decreases, no. Therefore if you travels to up to infinity, so then it is going to become like a one. So therefore these are parallel wavefronts, no. This we can call it as parallel or plane wavefronts. Plane wavefronts, right. So these wavefronts are what? Therefore these are nothing but a three-dimensional. I mean these spherical wavefronts are nothing but like a three-dimensional, no. So these are like a plane wavefronts onto this. Clear? Clear? So therefore if you take it as like a one extended source is there, no. This is one extended source. So this extended source will create it like a tube light is there, no. It is going to create like a one cylindrical wavefronts, no. Clear? So these are called like a cylindrical wavefronts. So this we will not use it much, no, but we will use first very important plane wavefronts, no. So second is nothing but a spherical wavefronts. First we will deal with only the plane wavefronts, no. So in this wave, right. So now you know that intensity is nothing but what, as it is very near, no, intensity so is inversely proportional to the area, inversely proportional to the area. So therefore intensity, so this is a spherical wavefronts, no, is inversely proportional to 4 pi r square. Intensity is inversely proportional to the square of the distance. So that means as you are going far away from this one, no, therefore intensity will be very less. And intensity is directly proportional to the square of the amplitude. This is an amplitude. So therefore here amplitude is inversely proportional to the radius in the spherical wavefronts. These all are 2 points, no, slightly important. Amplitude, this is what, not area, this is amplitude. This amplitude is inversely proportional to the radius, no, and intensity is inversely proportional to the square of the distance, no, right. So next very important, no, plane wavefronts, no. Plane wavefronts only we are going to deal it, no. So therefore intensity, these all are, so you see this is area, this area, therefore areas are same, no. Therefore intensity is inversely proportional to the area. So this area is constant, this area is not increasing, no, right. So area is constant, yes or no. Therefore for the plane wavefronts, no, intensity is it is nothing but a, intensity is nothing but a one constant value. it is constant. Clear? And intensity is directly proportional to the square of the amplitude. Clear? So intensity is constant in this one, no, plane wavefronts, no, and amplitude, no, therefore you can take it as a, this is your amplitude and intensity is always constant into this. Clear? Right? So cylindrical wavefronts we are not going to deal anything, no, therefore, so here you can write it as like a intensity is inversely proportional to the surface area of this one, no, intensity is inversely proportional to the r and amplitude is inversely proportional to the root r, right? Clear? Like that. Clear? Right. So this amplitude also, intensity is constant means amplitude also constant. Clear? So that's why we are going to use this concepts now. Clear? Right? So now how this ray diagrams, therefore how the formation of the image, and he explained, no, and he also says that in a denser medium the speed of the light is lesser and rarer medium speed of the light is larger. Huygens, what he said, no, he said that, so therefore in denser medium speed of the light in denser medium is smaller compared to the speed of the light in rarer medium, right? So therefore correctly explained onto this one, no. So and he explained reflection, refraction, no, how he explained, no, let us discuss now. So how Huygens, no, explain the reflection, refraction and formation of the images, no, let us discuss now. First in the let us see. So therefore this is one mirror is there, no, this is one mirror. We explain how Huygens, no, explain this reflection, no. So here, so now a plane wavefront is coming and falling here, no, therefore this is one plane wavefront, right? So this is coming here, one plane wavefront, you try to observe by the scale, no. So this plane wavefront is coming here, no, therefore this plane wavefront how it is making at certain angle, no. So this is one plane wavefront is coming here, no. First which one it is touching here now, this point is touching to this point now, therefore at this point, no, so which one, this wavefront is touching here, no, and at this point what is happening now, in which direction is moving, this is moving this direction and this is getting reflected back. Clear? So this is first one, no, this is first incident, no, this is getting reflected back, no, but this point it is going toward this side. That means once it is incident here, no, this point, no, then it is getting like this, no, like this, like this, like this, because this part is moving this side, no, this part is getting reflected first. So then it is getting like this, no, then it is comes to here, so then it will be comes to here like this, therefore then it will be able to move. Therefore you understand, no, this is coming here, no, this point is reflected, this point is moving downward, no, therefore it is getting like this and like this, and it is then it is this part is also getting reflected, then it is going out onto this. So in this way he explained therefore the reflection of our light, no. So this is your incident ray and this is getting reflected ray, and this is your angle of incidence and angle of reflection, both are same here, no, right? You can use the geometry and you can calculate it, no, here. Now how he explained again refraction, no, therefore this is one denser medium, this is one denser medium, this is one rarer medium. You know that speed of the light in rarer medium is greater than speed of the light in denser medium, right? So then a plane wavefront is coming and falling here, no, this is one plane wavefront is coming and falling here, no, clear? So now you try to observe it, no, therefore here, now what happens now, see here, this is one plane wavefront is coming with certain angle, no, now you try to observe here, no, so now which point is entering first now, this is not reflecting, this is refracting now, going into this medium. So what is happening now, this point is first, this point now it is entering first now, but this point is still it is in the air, clear? So therefore this point is entering here, no. So this point is entered, this point it is still in the air, that means this point it will get slowed down and this point is already in the faster, because this is in the air or rarer medium. So this is faster, no, this is slower. Why? Because this point is entering first, this will be slow down, this it will be the faster, therefore it will be slightly, it will travel this distance, will travel larger, no, then it will go, once it is entered, no, it will travel in the straight line, clear? So that means once it is coming, entering, no, so therefore here at this point, no, which one is entering first now, clear? So this point is entering first now, this is still in the air, this speed is larger, so this speed is slower, clear? Then what will happen now, this part it will get bent faster, no? Then it will go enter into this one, no? Clear? So then what will happen now? There this will travel lesser distance, no? So then it will travel more distance onto this. Then afterwards it will go in this direction here. Clear? So this distance is more, this distance is less. Clear? So this distance which is there, no? This distance, no? So which is larger and this distance is smaller. That's why it will bend toward the normal, no? Then we can use these triangles, no? Then you can apply the Snell's law. You know the Snell's law, no? N1, therefore refractive index into sin I is equals to Nd into sin R. Clear? You can use this triangle, no? Therefore you can able to derive it now, right? Here we are not going to derive anything, right? So this is a Snell's law. He explained on to this. Clear? Next one. So how the formation of the image will be there now? So therefore suppose here one concave mirror it is there now, concave mirror. Clear? So therefore here the one plane wavefront is coming and falling here now. This is one plane wavefront. Plane wavefront means what? Which is coming from infinity. So where the image should form now? Image should form on the focus compulsory. It should form on the focus. Clear? So this plane wavefront, you try to observe, no? This plane wavefront is coming and falling, you know, this plane wavefront. You try to observe this point, no? This point. So which point is incidenting first now? This point is incidenting here, this point is incidenting here. So this point is getting reflected first. Clear? This point is getting reflected first. So therefore, but this point you try to see that it is moving toward this direction now. So this point is moving toward this direction, this point and this point is moving toward this side. That means what will happen now? It will be able to bend like this. Clear? So it will be bent like this. Then after final reflection, no? Therefore what will happen now? So therefore here it will be able to bend like this. Therefore it is going to meet at the focus here now. Clear? So they are going to meet at the focus. Therefore here, so after final reflection, no? Therefore they are going to meet at the focus, no? So here the light rays after reflection, no? It is going to meet at this one, no? This is your final image. So object where it is there, no? At infinity. So image is formed at this point, no? Therefore after reflection it is forming like a spherical one, spherical wavefronts, no? Clear? Now suppose here there is a one convex mirror, no? I mean, right? So what will happen now? Suppose one plane wavefront is coming and falling here now. This is one plane wavefront is coming. Plane wavefront means what? Therefore this object is at infinity. Now this is coming here now. Listen carefully. Now you try to observe which point is incidenting here now. This point is incidenting first. This point is moving toward this side. This point is moving toward this side. That means what will happen now? This point is getting reflected. That means this point it will be able to move. This point is moving toward that side. So therefore what will happen now? After reflection it will be able to bend here like this. So therefore here first this is getting reflected, but this it is moving, no? Then after reflection, no? So therefore it will be able to go out. This is going out here. So that means this wavefront is coming from where, no? Coming from here, appears to be coming from here, no? So this is nothing but a focus. So if a plane wavefront is going to incident on a convex mirror, no? Therefore, so after reflection, no? It will form like a spherical wavefronts, no? Which is appears to be coming from the focus. Clear? Right? Next one. Suppose, right, so I am giving small work, no? Suppose here this is one concave, no? Therefore here there is a spherical wavefront is coming here, no? This is one spherical wavefront is coming now. So this spherical wavefront is coming, and after reflection, so which wavefront it will come out? So please comment it in right in this video now. Clear? So that means where it is there, no? Its focus is there. A spherical wavefront is coming and falling. So what will happen now? Right? Just please comment it, no? Right? So next one. Now we'll go for how the formation of the image is there from the lens now. Therefore this is your convex lens. Clear? So therefore this is one wavefront, no? This is one plane wavefront, no? Plane wavefront means what? Object is at infinity. We know that. So this is your denser medium, this is your rarer medium. Therefore speed of the light in denser medium is smaller than speed of the light in rarer medium. Now what will happen now? Suppose here this is coming here now first. So once first it is coming here, no, therefore this is first incident, no, this is you try to observe, no, this is in the air, this is in the air, clear? So therefore what will happen now, this is in the air, this is in the air, so this is first is entering, when this is entering, no, therefore the speed of this part, no, is decreasing, the speed of this part, no, is larger, because it is in the air, you understand, no? So once it is entered now, therefore it will be able to bend. But here also again, once it is coming, this is narrow, no? Once it is coming out, so which one part is coming out now faster? This part is coming out faster, but this part is still it is in the air, no? Sorry, in the medium. So this part is slower down, slow down, and this part is moving faster, no? So therefore here, finally, so what will happen now? Therefore the plane, the wavefront, no, it is going to come out like this, a spherical wavefront. Clear? So this is going to meet at this point, no, therefore it is going to meet, no, that's why you can call it as a real image. This is nothing but a focus. Clear? So in this way the image formation also explained by our Huygens, no. Next one, suppose you can go for concave mirror, concave lens, no. So this is one concave lens. So this is one plane wavefront, no, is coming here, no, this is one plane wavefront is coming here. So therefore which part is coming first now? This part is coming first, this part, no, this part. So but this part is in this, still in the air, no, this part it will be in the denser medium. Denser medium, you know that the speed of the light in denser medium is smaller than speed of the light in rarer medium. This side is rarer medium, this is your denser medium. So what will happen now? Therefore which part is entered now? This part is entered, this part is entered. So therefore what will happen now? This part, no, it will slow down, and this part, no, it will be move faster. Slow down means what? Therefore what will happen now? Here slow down, it will be bent like this. But once it is, which one will coming out first now? Center part is coming out first, no? Center part is coming out first. So then this edge part, no, still it is in the denser medium only. Clear? So after refraction, no, therefore here the spherical wavefront, no, it will go out. This wavefront is appears to be coming from here, so this is nothing but a focus. Clear? So in this way he explained the refraction, so formation of the images, no, and also do has one homework, no, homework. Suppose this is your convex lens, no, therefore here at the focus, no, at the focus, therefore there is a one point source is there, a spherical wavefronts are coming and falling on this. After refraction, no, therefore what wavefronts are going to come out, no, please comment it in this video. Clear? So as a homework, no, you do it. Now most important, no, therefore here there is a prism is there, no, therefore here prism, this is a denser medium, this is a rarer medium, a plane wavefront is coming and falling here, no. A plane wavefront is coming and falling here now. Clear? So this plane wavefront is coming and falling. Now what happens now? So this wavefront now is going on hitting onto this one. Which one is hitting now? So this part is entered, no, this part is slow down, this part it will be moves faster, no, then it will be bent like this, no, then it will be bent like this. So this will travel less distance, no, this travel more distance, no. So once it is entered, no, it will bend like this. But you try to see it now, which part is coming out first now? This part is coming out first now, this part is still it is in the denser medium, no. Finally when it is comes out, no, this part it will move faster, no. Therefore finally, therefore the plane wavefronts are going to come out. That's why emergent ray is always tends to the base of the prism, right? So therefore here this is called emergent ray, so it is always bent toward the base of the prism. Clear? You understood, no? So in this way, therefore he explained the refraction, right? So with the plane wavefronts now. Clear?